Okay, so if you recall from first semester, we have something called a polar coordinate. Polar coordinates lend themselves very well to vectors. Okay, if you recall from our definition of vector, a vector has a magnitude and a direction angle. Okay, a polar coordinate has a radius and a direction angle. So it turns out that the magnitude of our vector is going to be equal to the radius of a polar coordinate. So if I have a vector a comma b in component form and I wanted to write it in polar form, it would simply be this. Okay, so what we're going to do right now is I'm going to give you two vectors described in by magnitude and direction angle. Now, if you want to, what you can do to find the resultant, if you add the two, you can convert because you do have enough information to convert it back to its component form. There is another way to do this that uses law of sines and law of cosines. So for the first video that we're going to do, converting back to component form. And then for the second video, okay, we're going to do the exact same problem, but we're going to use law of sines and law of cosines. Okay, so here's our example. I have a vector v with magnitude of 300 and a direction angle of 70. I have a second second vector of magnitude 400 and a direction angle of 25 degrees. I want to find u plus v. I want to find its magnitude and the direction angle for the resultant. Okay, so first thing we're going to do is we're going to convert to component form. So our vector a comma b in component form is going to be equal to r cosine theta for the a, and then r sine theta for the b, or b. So u becomes 400 cosine 25, 400, whoops, forgot a zero, 400 sine 25. And then if I use my calculator, making sure it's in degree mode, I get 362.52. And then $169.05. Okay, and now my vector v, I'm going to do the same thing. So we're going to go 300 cosine 70 degrees, and then 300 sine 70 degrees. So 102.61. 281.91. Oops. Okay, so now we have our lovely vectors in component form. So now what we can do is we can take that information and use it to find u plus v. So u plus v, you're going to add 362.52 plus 102.61 horizontal components, and then vertical components, 169.05 plus 281.91 . So 465.13. And then $450.96. Okay, so now what we're going to do is we're going to find the length of that. Okay, again, you want to use your calculator, be very careful, because these problems have so many numbers that if you type something in wrong, let's just say it's highly annoying. Okay, here we go. 465.13, square that. Square 450.96, add those together. Get a really large number in the calculator, but remember you need to take the square root of that. So I get 647.85. And that's my magnitude. Okay, so now I get to find the theta. So we're going to use this formula right here. Now, luckily for me, everything is in the first quadrant, so that means everything is going to be nice. I don't have to do any sort of angle adjustments. So tangent of theta is equal to 450.96 divided by 465.13, where I use tangent inverse. Okay. And we get 44.11. All right, so that's the first way to do the problem. Now, so we're going to cover a second way to do the problem that uses law of sines and law of cosines. Okay, so that's the second video. So hopefully this helped.